In this video, we're going to look at vertical shifts of functions. And the cool thing about all transformations, including vertical shifts, is that when functions are written in function form, no matter what type of function it is, they all will do these same transformations. So if you can do it for one function, then you can do it for any function written in function form. Okay, so we're going to look at this function. It's not anything special. It's not linear. It's not quadratic. It's not a polynomial. It's just this random function that I drew. It's a function because it passes the vertical line test, and this is what we're going to be looking at. I also named this function f. So what we're going to look at is we're going to look at various transformations of this basic function. And what we want to focus on is we want to focus on what happens to the coordinates when we move the function around or when we transform it. So we're going to really focus on the 4 points that are really highlighted here, the maximums and minimums we see. So we'll have -4, 1. Down here is 0, -1. Up here we have 2, 3. And then we have 5. Nope, not 5, 3, 5, 2. So we want to see what happens to these ordered pairs as we transform the function in the coordinate plane. So what is a vertical shift? Because that is the focus here. So a vertical shift of a function is when the function moves up or down. And to demonstrate, I'm going to click out of the PowerPoint, and we'll just do this. And so basically what it means is that we would take the function and we would move it up or down along the same, so it's not changing location in terms of left or right, it's just moving up or down. But notice the shape is maintained. So that's all it's doing, which means if we think about what this is going to do to our ordered pairs, it's not affecting the x coordinates, it's affecting the y coordinates, right? The x coordinates are still -4, 0, 2, and 5. So how do we recognize a vertical shift? Let me go back to the PowerPoint. So we're going to go from current slide. So we would recognize a vertical shift because what would be happening is something would be added or subtracted to the function itself. So it would take on the form, we would say there's going to be a vertical shift if we have this new function g of x, that's f of x plus some constant, and that constant could be negative, so it might look like minus that thing. If we see something happening outside of the function being added or subtracted, that's an indication that it's talking about a vertical shift. So let's go to our next example. We're going to graph g of x based on our f of x, but it's going to be f of x plus 2. So what's this going to do to the function? It's going to take the function and it's going to lift it up 2 units, which means this 4, 1 is going to move up here to, -4, 1 is going to move up to -4, 3, because we would add 2 to the y coordinate. So on my new graph, -4, 3 would be here. And then this 0, -1 is going to move up 2 units, so it'll be at 0, 1. And 2, 3 is now going to be at 2, 5, so up here. And then lastly, 5, 2 is going to move up 2 units, so it will be at 5, 4. 1, 2, 3, right here. And if I connect these, I'm going to do the best I can. As you know, I have a hard time writing on this since I can't press my hand against the computer. Oh, that wasn't so bad. So as you can see, the shape is maintained, but it's moved up in the plane. That's what it means to have a vertical transformation. And our last example for vertical transformations, now we want to graph a new g of x where it's f of x minus 1. So again, what's going to happen here is the whole graph, we're going to pick it up and move it down 1 unit. So we just focus on those 4 endpoints because those are the ones, if we just connect them, it kind of creates the entire graph. So this -4, 1 is going to move down to -4, 0. 0, -1 is going to move down to 0, -2. 2, 3 will move down to 2, 2. And 5, 2 will move down, well, let me show it here, move down, and this one moves down to 5, 1. I'm going to do my best to connect these. And so the graph should maintain the same shape, but everything shifted down 1 unit. So basically what it does is it affects the y coordinates. Those are vertical transformations.